Today we're going to talk about section 7.4, product to sum and sum to product formulas. Turns out products can be converted to sums and sums can be converted to product formulas. Okay, let me explain this to you by recalling this formula that we covered in the last lecture. Sine of alpha plus beta equal to sine of alpha cosine of beta plus cosine of alpha sine of beta, right? First formula. Second formula, sine of alpha minus beta. Intuitive formula, sine of alpha cosine of beta, minus here, cosine of alpha sine of beta, right? Good. Now, what if we add these two equations component-wise? Add these two. Adding these two, I will get sine of alpha plus beta plus sine of alpha minus beta, right? For this left side of the equation. On the right side, these two guys will cancel and I will get the sum of these two components, but they are the same, right? They are the same. So basically, after canceling these two, right, I should get just twice sine of alpha cosine of beta, right? Twice this. Very good. Now, dividing both sides of this equation by the number 2, right, these two, in order to isolate this product, that's my intention. This is what will happen. Look, divide this by 2, divide this guy by 2. We're gonna get here that these two will cancel with these two. Sine of alpha times cosine of beta, right? Which I can write here, equal to 1/2 of the sum, 1/2, right here, 1/2 of, use brackets, the sum of sine of alpha plus beta plus sine of alpha minus beta, right? Close the brackets. So as you can see, a product can be expressed as a sum, right? That's the idea. Okay, I show you how many mathematicians figure out how to express this product as a sum, right? It's an example for you to look at the background of this. But now I'm gonna show you the list of products turned into sums that mathematicians have figured out following the same ideas I gave you before, right? There are 4. The first one, product to sum formula, is cosine of alpha times cosine of beta equal 1/2 of cosine of alpha minus beta plus cosine of alpha plus beta. Second one is sine of alpha times cosine of beta equal 1/2 of sine of alpha plus beta plus sine of alpha minus beta. The third one, sorry, sine of alpha times sine of beta equal 1/2 of cosine of alpha minus beta minus cosine of alpha plus beta. The fourth one is cosine of alpha times sine of beta equal 1/2 of sine of alpha plus beta minus sine of alpha minus beta. Now, these 4 formulas are difficult to memorize, right? So I have placed them in our website. Also, you can have access to it through Blackboard. If you go to course materials, useful sheets, it's there. Where? Here. Let me show you. We are talking about these first 4 formulas, right? This guy is here, this guy is here, guy is here, this guy is here. Okay, so print this out, have it handy, right? We're gonna use them to go from products to sums. You may see here differences, right? Difference is considered to be a sum because it's addition of the opposite, right? So in general, products to sums. Okay, great. Let's move on then now. If we move on now, let's see an example. Example 1. Use the product to sum formulas to rewrite cosine of 41 degrees times cosine of 3 degrees as the sum of two functions. Solution, here you see cosine of 41 degrees times cosine of 3 degrees equal to what? Well, I am going to call this angle 41 degrees alpha and this angle 3 degrees beta, okay? If I do that, I'm trying to turn this into a sum. So if you look up here, there is a way to turn the multiplication of two cosines as a sum, right? So let's do that. Alpha 41 degrees again, beta will be 3 degrees. Let's use the formula, the first one, right? You gotta use these formulas accordingly. All right, so that will be then equal to what? 1/2 of cosine of alpha minus beta, but alpha is 41 degrees minus beta 3 degrees, plus cosine of 41 degrees plus 3 degrees, right? The sum of alpha and beta. And now we just have to simplify this, right? This will be 1/2 of cosine of 41 degrees minus 3 degrees is 38 degrees, right? Plus cosine of 41 degrees plus 3 degrees, cosine of 44 degrees, right? If this sum gets complicated, you can use your calculator, right? Great. Almost done. Now, simply distribute the multiplication of 1/2 over this sum, okay? This way. This will be finally equal to 1/2 of cosine of 38 degrees plus 1/2 of cosine of 44 degrees, okay? And then we are done, right? We turn this product into a sum. Great. Very good. Example number 2. But before we go over example number 2, which is basically the same as we did here, but with variables, which is the last goal, right? I want you to practice, guys. I'm gonna let you practice here on the worksheet, something similar to what I just did. I will show you the formulas. You can have it there in your sheet, right? Formula. So for example, could you try number 1? Number 1 here. Let me make it a little bit bigger. Yeah. Number 1, do this. Turn this multiplication cosine of 49 degrees times cosine of 12 degrees into a sum. And for that, recall, I'm gonna remind you about the formula that cosine of alpha multiplied by cosine of beta is equal to 1/2 of cosine of alpha minus beta, this is in our sheet of formulas, plus cosine of alpha plus beta, right? Do this, please. Give you some time. Try to figure out what is the answer. The hint also, right? Remember, let the first angle here be alpha or play the role of alpha. The second angle should play the role of beta, right? Yeah, go ahead. So try. Yeah. Yeah, as long as you have the formulas, it shouldn't be difficult, right? It shouldn't be difficult. So have those formulas again printed out or handy somewhere, right? So you can look at your formulas, okay? Very good. All right, so let's do it together, okay? Cosine of 49 degrees times cosine of 12 degrees, following the formula, should be equal to 1/2 of cosine of 49 degrees minus 12 degrees plus cosine of 49 degrees plus 12 degrees, right? But what is this? This will be 1/2 of cosine of 49 degrees minus 12 degrees. Take our calculator. 37 degrees, right? 37 degrees here. Plus cosine of 49 degrees plus 12 degrees. 49 degrees plus 12 degrees is 61 degrees, okay? 61 degrees. And then just distribute the multiplication of 1/2, right? That's all you gotta do, guys. 1/2 of cosine of 37 degrees plus 1/2 of cosine of 61 degrees, right? And this should tell us that the answer is just this guy, right? Follow, guys? Very good. Yeah, this one, try to do it. It's a little bit different, but deals now with turning the multiplication of sine of 32 degrees times cosine of 3 degrees into a sum, right? Into a sum. Into a sum. So we're gonna use a different formula, right? So I'm gonna give you the set of formulas here for you to see. Look here. We have to use now sine times cosine, right? You look for the form, sine times cosine. There is an order involved in the products, right? For the forms, be careful there. Sine times cosine, right? This is the one that we have to use, right? Follow, guys? This. Use that and try to convert this into a sum. Okay. All right, let's do this together, okay? So this will be equal to 1/2 of, remember, first was sine of the sum, right? The sum going to the formula. So 32 degrees plus 30 degrees, 3 degrees plus, then was sine of the difference, right? The second formula. 32 degrees minus 3 degrees. This equal to 1/2 of sine of 32 degrees plus 3 degrees, 35 degrees, right? Plus sine of 32 degrees minus 3 degrees, 29 degrees, right? Very good. Now, just distribute the multiplication of a half. So 1/2 of sine of 35 degrees plus 1/2 of sine of 29 degrees, right? Great. Okay, so now the goal, as I said, right, is to do this, what we just did with numbers, with some terms containing variables, something like this, right? I will show you, I will give you an example first, and then we will come back to the worksheets, okay? All right, so let's go back to our notes. Here is an example. Express the following product as a sum containing only sine or cosine, and no products, no products. Basically, turn this multiplication into a sum, right, of trigonometric functions like sine and cosine. All right. Again, start by writing out sine of 4x times cosine of 2x. And let this guy behave like alpha. Let this guy be beta, right? And choose a formula that allows you to do this. Basically, look at this here, your sheet of formulas, right? First set here, look for sine first and cosine next. Sine, cosine, is the second formula, right? The second formula. So the second formula is telling us that sine times cosine is equal to 1/2 of sine of the sum of the angles plus sine of the difference of the angles, right? So let's apply that formula. So this should be equal to 1/2 bracket sine of the sum of the angles 4x plus 2x plus sine of the difference of the angles, right? Sine of the difference of the angles will be 4x minus 2x. Very good. Bracket here. So this will be 1/2 of sine of 4x plus 2x, 6x, plus sine of 4x minus 2x, twice x, right? And finally, just distribute the multiplication of a half, 1/2 of sine of 6x plus 1/2 of sine of twice x, okay? Now, here guys, a warning. Often students ask me, Professor, can I cancel this 2 with this, or simplify, better said, this 2 with this 6, 2 into 6, 3? The answer is no. Don't do that, guys, because there is a sign here sort of protecting this 6x, right? There's no rule that says you can cancel here. Without the sine function, then yes, you can cancel, but with the sine function, no. Leave this alone. This should be the answer, okay? This is the answer. Leave this alone, right? Same thing here, right? Do not cancel this 2 with this 2. Leave it alone. That is the answer. Great. Now, let's see if you can do this on your own, okay? Let me show you a worksheet where you can work on, okay? Work on this one, guys, now. Number 3. 3 is good. It's showing there multiplication of cosine times cosine. Try to turn that into a sum or a difference, right? Yeah, you do this. A little bit bigger. Yeah. Try to do this, guys. Cosine of 4 theta multiplied by cosine of 7 theta. Do not confuse this theta with a 0, right? It's not 0. This is not 40. This is not 70. It's 4 theta, the Greek letter theta, right? Cosine of 7 theta. Turn this into a sum. And for that, I'm going to show you here the formulas. Look, we are dealing with cosine first, next cosine. So look for that. The first one, right? Cosine, cosine. Use this formula. 1/2 of cosine of the difference plus cosine of the sum. Okay, use the formula. Go ahead. Yeah, this formula. Yeah, try guys, and then we will move on. You can see it's not that difficult. It's just a matter of having these formulas handy, right? And then applying them accordingly. All right, guys. So let's do it together, okay? I'm going to use the first formula, right? 1/2 of cosine of the difference plus cosine of the sum of the angles, right? So 1/2 of, and one more time, probably this helps. This is going to be alpha, this is going to be beta, right? For the formula. So the formula says 1/2 of cosine of the difference alpha minus beta, but that is 4 theta minus 7 theta, plus cosine of the sum, 4 theta plus 7 theta. Okay, very good. 1/2 of cosine 4 theta minus 7 theta, since this is the dominant in value, is minus 3 theta, right? Minus, right? Plus cosine of 4 theta plus 7 theta, 11 theta, right? 11 theta. 1/2 of. Now, notice cosine of theta, recall, I'm going to emphasize, recall. Cosine of alpha negative or negative alpha is the same as cosine of alpha. It's a property, right? Property. Cosine of negative alpha equal cosine of alpha for all alpha, right? For all alpha. So we apply the property here and we can get rid of that negative sign. We can say that this is cosine of 3 theta, okay? 3 theta plus cosine of 11 theta, right? So get rid of negative signs if they appear using this property. Now, finally, just distribute the multiplication of 1/2 over. This will be 1/2 cosine of 3 theta plus 1/2 cosine of 11 theta, right? And then look back for the answers, and you can see that this is this guy, right? 1/2 cosine 3 theta plus 1/2 cosine 11 theta. They have dropped the parentheses for the angle. You can see that, right? Great. So we're good with this form. Now to reinforce this and move on, try to do this, guys. Yeah. This is gonna be on your final exam, so please make sure that you know how to do this, right? It's an important transformation. This will help you when you take calculus 2, when you do the process of integration, right? Turning a product into a sum will allow you to do the process of integration or taking antiderivatives, but that will come later in calculus 2, right? Now they're just helping you out here in pre-calculus. All right, great. So try to do this. Try to turn this sine of 5 theta multiplied by sine of 7 theta into a sum or into a difference. For that, we're gonna bring up the formulas and see which one we can apply accordingly here. Notice I have sine first, then sine again. So look for one that says that. Look here, sine first, next the right sine again, right? There is an order there for the forms. This is the one that we have to use now, right? 1/2 of cosine of alpha minus beta minus cosine of alpha plus beta, right? This is what we have to use, okay? Use that, figure this out. Use some time for that, then we will move on. Okay, great. Let's do it together. Very good, very good. So we're going to use again the third formula, right? 1/2 of cosine of the difference first minus cosine of the sum, okay? Yeah, we're going to use the third. So this will be equal to 1/2 of cosine of the difference first. Cosine, remember this guy is alpha, this guy is beta, right? Alpha minus beta first. So 5 theta minus 7 theta, right? Minus cosine of the sum, alpha plus beta, but alpha is 5 theta, beta is 7 theta. That's it, right? Very good, very good. There we go. So then 1/2 of cosine of 5 theta minus 7 theta is negative 2 theta, right? Negative 2 theta. Notice this is the dominant in value. Minus cosine of 5 theta plus 7 theta, 12 theta, right? 12 theta. Very good. Almost done. Now, remember, this negative sign can be taken away by following the property I show you, right? Cosine doesn't care about the sign of the angle. So cosine of minus alpha equal cosine of alpha for all alpha, right? So applying that property, this becomes cosine of twice theta minus cosine of 12 theta, okay? Great, and finally, just distribute the multiplication of this 1/2 cosine of 2 theta minus 1/2 of cosine of 12 theta. And again, warning guys, do not cancel this with this because there is a cosine there protecting this 2 theta, right? Leave this alone. Here the same, very tempting to do 2 into 12 is 6. No, don't do that, leave it alone. It will appear there as it is. It's choice B, right? Follow guys? Yeah, very good. Great, so now let's continue. Now we're gonna do this the other way around. Notice now, this is a difference. They want you to turn it into a product, right? It is possible. It's possible to turn a sum into a product. Mathematicians have figured it out. And I will explain this to you now. Next. We did product to sums. Now let's do the other way around, sums to product. How does that work, Professor? Well, here I will explain it to you now. It's called the sum to product formula. Manipulating the formula that we have learned before, right? As I showed you at the beginning of this lecture, right? It is possible to obtain these 4 results. Mathematicians have done it, and they are presenting them to us here, these 4 formulas, right? To turn sums into products, sum into product. You may say, Professor, there's a difference there. Yeah, a difference is considered sum because it's addition of the opposite, right? So in general, they say, they call these sums, they call this product, right? Sum into product, the other way around. Okay, we're gonna use these 4 formulas. These formulas are difficult to memorize, so I have put them on the website here. It is. And their course materials, useful sheet is there. These are the 4 formulas, okay? This is the first one, second one, third one, the fourth, right? And we will apply them accordingly, right? According to our needs. And notice that there is an order for the forms, right? So according to the form that you are dealing with, you choose your formula, right? Yeah. Great. So let's see an example, right? A concrete example. Example 3 says use the sum to product identities to rewrite the expression as a product. Okay, this expression, this difference, right? They want you to write it as a product. Okay, good. Yeah, we have formulas to do that, right? Yeah, very good. Yes, is that very bigger? Yeah, great. So we start by writing out the sine of 44 degrees minus sine of 38 degrees, okay? Well, clearly, since I'm dealing with sine minus sine, when you look through these formulas, the second formula is the one that I have to choose, right? The second one, sine of alpha minus sine of beta. Very good. We're going to use the second formula. Again, call this alpha, this angle, call this angle beta, right? And apply the second formula. The second formula says that this should be equal to 2 times sine of this semi-difference, right? Semi-difference, alpha minus beta. So alpha is 44 degrees minus beta 38 degrees, all that divided by 2. Multiply by the cosine of the average of these 2 angles, right? The semi-sum, 44 degrees plus 38 degrees over 2. Great. And the rest is just to work this out. Do you see? Sine of what? what is 44 minus 38 divided by 2? Well, we can use our scientific calculator. 44 minus 38, all that divided by 2 is just 3, right? 3. And I'm showing this with a calculator because in your homework probably will get big numbers that are difficult to deal with. So use the calculator. That was the semi-difference. Now the semi-sum, or the average now, right? 44 plus 38. All divided by 2. That is 41, right? 41. And that's pretty much it, 41. So 41, let's put the degrees here. That's it. This is the answer, right? We have turned, notice, a sum into a product, right? Into a product. Great. All right. Now, before I go to the goal, which is to do this with variables, right? Let's practice on this first, right? On this part, this form. So let's go back to the worksheets. And let me show you an example here that we can go over. Here we go. It's a good one. Number 5. Can you try number 5? Maybe some time for you to do number 5. Do this. Turn this difference into a product. Sine of 43 degrees minus sine of 27 degrees, right? Turn this into a product. And for that, I'm going to show you the formulas here for you to identify which one you have to use. We are using the second set of formulas, right? This. Look, sine minus sine. So you look for a formula that says sine minus sine. The second formula is saying that, right? So we're going to use the second formula, okay? This one. Yeah, try. Use your second formula. Figure this out. Very good, guys. Apply the formulas accordingly, and you should be fine. Great. Okay, so let's use the second formula, right? Let's use the second formula, which says sine of the semi-difference times multiply by cosine of the semi-sum. Okay, very good. So this will be equal to, letting this be alpha, letting this be beta, and try to remember this for your homework. This will be equal to 2 times, right? Sine of alpha minus beta over 2, but alpha is 43 degrees minus beta 27 degrees divided by 2, multiply by cosine of alpha plus beta over 2, but alpha is 43 degrees plus beta 27 degrees, all that divided by 2, right? Very good. Twice 43 minus 27 divided by 2. Let's figure this out in our calculator. 43 minus 27, like this, divided by 2, 8, right? 8. I'm showing you this with a calculator so you guys, when you do your homework, if the numbers are not friendly, you can handle this using mental mathematics. You can always do that using the calculator. Look, this is another option. You click here on fraction form, you type on the top 43 plus 27. On the bottom, you type 2, right? It's like the average of the angles for this part. 35 degrees. Excellent. 35 degrees here. Right, and this is pretty much it, because this is the sum turned into a product, right? So you look through for number 5, and the answer should appear there. Very good, guys. So this one, right? Now you may say, Professor, they wrote this on the end, this first. Remember, the order of the factors do not change the product, right? Community property. So as long as the two factors appear there in any order, it's fine. This is it. Great, guys. Moving on. This one, you have to do it in radians, but I hope this shouldn't be a problem. And maybe I should show you how to deal with this case, because sometimes students ask me in the homework, you may encounter something like this, right? I'm going to show you how and it is possible to turn this difference into a product, okay? Again, first step, let one angle be alpha, let the other angle be beta, and apply a formula accordingly, right? Look at the set of formulas. The formula that I'm going to apply here, since I have sine minus sine, is the second one, okay? The second one is 2 sine alpha minus beta over 2 multiplied by cosine alpha plus beta over 2, okay? Let's do that. So this will be twice sine of alpha minus beta over 2, right? So pi over 13 minus pi over 2 over 2 multiply by cosine of alpha plus beta over 2, pi over 13 plus pi over 2 over 2, right? Very good. Now let's do the math here, right? The math is going to be a bit challenging because there are fractions involved, but don't get freaked out. 13 and 12, they have LCD. 13 times 12, 26, right? So this 13 should be multiplied by 2, the other guy, and this should be multiplied by 13, right? By 13. So you're going to get sine of 2 pi minus 13 pi on the top divided by 26 common denominator, right? All divided by 2 here, right? First. Times cosine of this guy times 2 times 13 times 13, right? By the same reason we did this here, right? LCD is 26, right? So we're going to get here 2 pi plus 13 pi all over 26 and all divided by the number 2, right? Divided by the number 2. Now, what happens on the top here? 2 sine of what? 2 pi minus 13 pi is minus 11 pi, right? Minus 11 pi over 26 all over 2. Cosine here of 2 pi plus 13 pi is 15 pi, right? 15 pi over 26 all divided by 2. But now, guys, remember, when you divide a number by a fraction, 2 is the same as 2 over 1, right? This divided by 2 over 1 is the same as multiplying this fraction by the reciprocal of this guy, 2 over 1, right? Which is 1/2. So finally, this will become 2 times 1. And also remember, when you deal with sine, recall, sine of minus alpha is equal to minus sine of alpha, right? Minus sine of alpha. So let's take the sine outside once and for all. And we will stay with what? Sine of this guy. Look, multiplying this by 1/2, 1 times 11 pi is just 11 pi, right? But this times 2 on the bottom, 52, right? 52, great. Same idea here, cosine of what? We have to multiply this times 1/2, right? 1/2. 1 times 15, 15 pi, right? On the bottom, the 2 on the bottom, 2 times 26, 52. And this should be it, right? Follow, guys? Now look through. Look for the one that is showing this is this one, right? You may say, Professor, but this guy first here at the end. Doesn't matter the order, okay? This is here, this guy is here, the negative sign, the 2 here, right? Cosine and sine there. Very good, guys. So be careful when you pick your answer, right? Choose the one that has the 2 factors, the negative 2 up front. Very good. All right, this is in case they want you to do this with radians, right? This angle for expressing radians is the same formula. It's just a little bit challenging to do the sum. Use the LCD, right? Your knowledge of adding fractions and subtracting fractions, and you should be okay. Okay, great. So now the goal is to do this with variables, right? As we explained. So in order for us to do this, let me show you examples, and then we'll go back to this part. So we can practice here, okay? So go back to a lecture. And let's do this now with variables, right? Write the following expression as a product. Sine of 4 theta minus sine of 2 theta. Write this as a product, okay? All right. So remember, in order to do that, look at your formulas, right? On the second set, and identify which one you need, right? Which one you need here. So here clearly sine first minus sine again is this, right? Sine of alpha minus sine of beta. This is the form that I need to deal with this, right? So the second formula. So it's twice sine of alpha minus beta over 2 times cosine of alpha plus beta over 2, right? So let's do that. All right, so twice, remember, this should be sine of alpha minus beta, sine of alpha minus beta over 2, but alpha is just this guy, beta is this guy, right? 4 theta minus 2 theta over 2 multiplied by cosine, because the semi-difference, semi-sum now. 4 theta plus 2 theta over 2, right? Great. Now, this is going to become 2 times sine of 4 theta minus 2 theta is just 2 theta. 2 into 2 theta, just theta, right? Just theta. Follow, guys? Just theta. Very good. That's the first part, right? Or maybe just let's write it so nobody gets confused here. Cosine of 4 theta plus 2 theta, 6 theta, right? 6 theta here over 2, right? So simplifying, sine of the 2 cancel with the 2, just theta, multiply by cosine, let's use parentheses, 2 into 6, 3, right? 3 theta, and that's it. 2 multiplied by sine of theta plus cosine of 3 theta is the answer. Sum into product. And you may say, Professor, what is it good for? Well, when you take calculus 2, I explained, doing this transformation will allow you to take antiderivatives, what they call integrals at that point, right? Okay, great. All right, so let's practice on this, guys. Let's go back to the worksheet, okay? Go back to the worksheet. Let's practice on this. Worksheet here. Going back to the worksheet, let me give you a chance to practice, okay? And then we will do some other forms. With variables now. Sine, yeah, we did this with numbers. We need to do it with variables. What about this? Number 7 for now. Can you try number 7? Do this. Turn cosine of 6x plus cosine of 4x into a product. Hint, let the first angle be alpha, let the second angle be beta, okay? And use one of the formulas here accordingly. Look, these are the formulas that we have available on the second set, right? I'm dealing with this form now, cosine plus cosine. So look for that. Cosine of an angle plus cosine of another angle. Here, the last one, right? We're going to use the last formula now. So use this formula turn this into a product, right? As I did in the example. So go ahead, guys. Go try. Give me some time to try. Mhm. And remember this, guys, it's going to be on your final exam. So make sure you master this topic. It's an important section, a small section though, but it's needed to complete the knowledge that you need to have to take your final exam. Okay, so make sure you're okay with this. All right, let's do it together. Okay, so clearly we have to use the last formula, right? Because it's cosine of an angle plus cosine of another angle, right? Yeah, so let's use the last formula. 2 times cosine of the semi-sum multiplied by cosine of the semi-difference. All right, let's do it. So this will be equal to twice the cosine of alpha plus beta over 2, but alpha is 6x plus beta 4x over 2 multiplied by cosine of alpha minus beta over 2, alpha 6x minus beta 4x over 2. All right, so this will be 2 times cosine of 6x plus 4x is just 10x, right? But you must divide that 10x by 2, multiplied by cosine of 6x minus 4x. This is just 2x divided by 2, right? Now 2 into 10 is just 5. So this will be cosine of 5x multiplied by cosine of 2 into 2, 1x, right? That's it. This is the answer. Look for it. It's here, right? Very good. Number 7. Excellent. For number 7, we're done then. Now, there is another one here. Can you practice on this? Do this. It will help in your homework. It will help you with your final exam too, okay? Yes, number 8. I have the list of formulas here for you as a hint. Call the first angle alpha, the second angle beta, right? You are dealing with a sine of an angle plus the sine of another angle. So sine of an angle plus sine of another angle. The first formula, right? The first formula now. Use the first formula, transform that sum into a product. Go ahead. Great, very great. So, okay. First formula, right? First formula. All right, let's do it together so we can go over more forms. Okay, so using the first formula, sine of 10x plus sine of 4x, calling this angle alpha and calling this angle beta, we're gonna have, this is equal to twice, remember twice, sine of alpha plus beta over 2, but alpha is 10x plus beta is 4x over 2 multiply by cosine of alpha minus beta over 2. So 10x minus 4x over 2, right? Very good. So then just do the math. 10x plus 4x, 14x, right? So this is going to be 14x over 2 multiplied by cosine of 10x minus 4x, 6x over 2. Okay. Simplifying 2 into 14 is 7. So sine of 7x multiplied by cosine of 2 into 6 is 3x here. So final answer 2 times sine of 7x multiplied by cosine of 3x, right? Look for that. I think it's very good. 8. Excellent. Now, before we move on to more forms, let me show you how, in this example, how these formulas to go from sum to products could be used to compute exactly, or what mathematicians call in exact form, certain sums, right? For example, this. And this is probably something that you may use in your homework. So let me show you how this works. All right, so suppose they say express the sum or difference as a product, right? Well, you follow the instructions and then you have to look at the set of formulas here. We are dealing with cosine plus cosine, so look for that. The last one, right? 2 cosine of alpha plus beta over 2 multiplied by cosine of alpha plus beta over 2. Beta over 2, right? So the last formula, use that. So this will be, so you set this to be alpha, this to be beta. So you will get 2 cosine of alpha plus beta over 2, 75 degrees plus 15 degrees over 2, multiply by cosine of alpha minus beta, 75 degrees minus 15 degrees over 2, right? Over 2. But this becomes cosine of 75 degrees plus 15 degrees is 90 degrees, right? 90 degrees over 2. Cosine of 75 degrees minus 15 degrees is 60 degrees divided by 2. This is equal to 2 cosine of 45 degrees, right? Multiplied by cosine of, which is 2 into 90, right? 2 into 60 is 30 degrees. Great, right? Almost done. Now, cosine of 45 degrees, remember from our unit circle, is just a square root of 2 over 2, right? I have memorized the result, but in case you're not sure, you don't remember, look always at your unit circle, you will find it there. 45 degrees, you can see. The first coordinate is cosine, the second coordinate is sine, right? Cosine of 45 degrees is indeed square root of 2 over 2. Great. Now, cosine of 30. For cosine of 30, this is cosine of 30, this is sine of 30, right? It's square root of 3 over 2. Square root of 3 over 2, cosine of 30. Square root of 3 over 2. And then just multiply them, right? Look, 2 cancels with 2. Square root of 2 times the square root of 3 is square root of 2 times 3 is square root of 6 over this 2, right? That's it. And this should be the answer, right? So you can see these techniques may help you to simplify, right? Try to remember this on your homework. Suppose they ask you to simplify this expression, cosine of 4t minus cosine of 2t, all divided by sine of 4t plus sine of 2t. Let's see how we can use our formulas to turn sums into product and deal with this, right? Yeah, great. So notice if we use our formula to turn the sum into product, we can say that this guy is the same as the following. Cosine minus cosine here is shown on formula number 3 is negative 2 sine of alpha plus beta over 2 multiplied by sine of alpha minus beta over 2, right? Notice there is this peculiar negative sign there. This sometimes students tell me, Professor, is that a typo? No, none of the other have negative sign. No, guys, it's not a typo. It's just the way the formula is. Don't forget, for the third formula, there is a minus in front of the number 2, okay? Yeah. So this formula should be equal to minus, then minus what? Minus 2 sine of the semi-sum multiplied by sine of the semi-difference, right? Yeah, let's do it. So minus 2 multiplied by sine of alpha plus beta over 2. But remember, this is alpha, this is beta. So 4t plus 2t divided by 2 multiplied by sine again, right? Sine again. Alpha 4t minus beta 2t over 2, right? Yeah, I have used the formula, right? This guy, as you can see, minus sine alpha plus beta over 2 times sine alpha minus beta over 2, right? Correct? Great. Now we got to deal with this guy, sine plus sine. So for that, I am going to use the first formula now, the first formula, right? So let's do that. Sine 2 times sine of alpha plus beta over 2 multiplied by cosine of alpha minus beta over 2. So let's use the first formula. So following the first formula, this guy becomes this. 2 times sine of alpha plus beta over 2 multiplied by cosine of alpha minus beta over 2. Okay, very good. All right. Now, this becomes then, after canceling these two, minus 1. Sine of 4t plus 2t is 6t, right? 6t. 2 into 6t, 3t, right? Here, sine of 4t minus 2t is 2t. 2 into 2t, t, right? Just t. Similarly here, 4t plus 2t, 6t. 2 into 6t, 3t, right? 3t. Cosine of 4t minus 2t is just 2t. 2 into 2t, just t. This guy cancels with this guy. Final answer minus sine of t over cosine of t. But sine over cosine, according to the quotient identities, is just tangent, right? Tangent. So this will be the last version of the answer, minus tangent of t, right? Minus tangent of t, that's it. So as you can see, you use the formulas and then you simplify, right? Whatever is common on the top, on the bottom, factor-wise, right? These two factors are the same, you eliminate them, and then you stay with whatever is left. Okay, following this technique, guys, I want you to try the following. Let's go to the worksheets. Let's go to the worksheets. Let's do at least one here. Yeah, this one looks good. For the sake of variety, yeah, let's use this one now, number 13, okay? The others you can do it at home. Let's do this. Can you try this? I will show you I will leave you the formulas here for you to choose accordingly which one you're going to use, right? Notice on the numerator, we have cosine minus cosine. So for the numerator, clearly, we have to use the first one, right? For the numerator. Yeah, this is cosine minus cosine, the third one for the numerator. For the denominator, the fourth one. Look, this one, right? Follow it? Look, this guy, as we use for the numerator, cosine minus cosine. This guy for the denominator, right? Cosine plus cosine. Let's do it. Try. Then we'll do it together. Okay, let's do it together. Notice that this becomes the following once you apply the formulas that I mentioned. Cosine minus cosine, remember, is negative 2 times sine of, is the third formula, right? The sine of alpha plus beta over 2. So alpha is 5x plus beta 9x over 2. Multiply by cosine. Yeah, actually sine again. Sine of alpha minus beta over 2, right? This is the formula. That's the numerator. The denominator, cosine plus cosine, has this formula. Twice is the last formula on the set. Cosine of alpha plus beta over 2, so 5x plus 9x over 2, multiply by cosine of 5x minus 9x over 2, okay? All right, so now doing the math here, notice this becomes the following. After canceling this 2 and 2, 2 into 2, 1, on the top, we end up with sine of what? 5x plus 9x, 5x plus 9 is 14x, right? 14x, but 2 into 14x, 7x, right? 7x. Similarly here, 5x minus 9x is negative 4x, right? 2 into negative 4x is negative 2x, right? Very good. This guy, cosine of 5x plus 7x, 14x, right? 14x. 2 into 14x, 7x, right? Here, cosine 5x minus 9x minus 4x, right? Minus 4x. But 2 into minus 4x minus 2x, right? Minus 2x. Very good. Now, guys, look at this. Sine of 7x divided by cosine of 7x. This is just tangent of 7x according to the quotient identities, right? Similarly here, look, cosine of negative 2x divided by cosine of negative 2x, tangent of negative 2x, right? Right. But now, notice this negative sign for the function tangent, recall for the function tangent of negative alpha, it's on the side, right, is equal to minus tangent of alpha, right, for any alpha. So let's use this fact, and then the negative sign comes out, but negative and negative multiply positive, right? So final answer should be tangent of 7x multiplied by tangent of twice x, right? Twice x. Again, the negative sign came out, but negative times negative positive. So this will be the final answer. And that's what you look for, is this guy, right? Follow, guys?